So we got to be careful with these ladder problems because they're going to give us different information. We have to make sure we know what information we're given, and we have to make sure that we're labeling this picture correctly. That's why we're drawing a picture, so we can better visualize what we're given in the question and what we have to look for. So it says the base of the ladder is 9 feet from the base of the building. That's going to be this measurement right here. Okay, here's the base of the ladder, here's the base of the building. The distance between those 2 points is 9. Okay, that's my first piece of information. The side of the building is 12 feet tall. That's my second piece of information. That's going to be this measurement right here. This side of the building being 12 feet tall. So when we set up our equation, a squared plus b squared equals c squared, which variable is not going to get replaced with a number? A, b, or c? Which variable will not get replaced with this 9 or this 12? Victor? B? C, right? C is my ladder. C is my hypotenuse, directly across from the right angle. That always has to be my C. So that's the variable that we're missing. That's what we're going to solve for. 9 squared plus 12 squared equals C squared. Now, I had someone yesterday tell me or ask me, well, shouldn't 12 be my C because it's the biggest number? Technically, yes, 12 is bigger between 9 and 12, but the hypotenuse needs to be the largest of all 3 sides. We don't know what our C is equal to, so we can't say with confidence that 12 is our longest side. Right? That's why it's important to understand what's going on in the question and how that translates to our picture that we're drawing. Now we can just solve this out, right? 81 plus 144 equals C squared. What is 81 plus 144? 225. We recognize that number now, hopefully. Perfect square. We take the square root of both sides and we get C is equal to 15. Now, what's my units here? Feet. 15 feet. Not just 15 units, 15 feet. Right? Now let's take a look at number 2, because number 2 looks almost identical, but is actually very different. Let's get our drawing going again. There's my little building. There's my ladder. And there's the space in between. So now, the first piece of information we're given is the ladder is 11 feet long. Is that going to be my A, my B, or my C? My C, right? The ladder is always C. The ladder is always C, so we're going to say that C is equal to 11. Now in this problem, the building is 9 feet tall. That's going to be this distance here. And what we're looking for is how far is the base of the ladder from the base of the building. We'll call that distance B. Now technically you can call it A as well, perfectly fine. But in the notes we focused on solving for B, so that's what I'm going to do here. You guys see how these two problems are different based on what information we're given? Because now we have a number to plug in for C, but we do not have a B. So our setup here is 9 squared plus B squared equals 11 squared. Again, notice how in number 1, our missing variable was C, but in number 2, our missing variable is B. That's because we were given different information in this problem, or I guess in each problem. So we're going to solve this a little bit differently than we did up there. 81 plus B squared equals 121. But now instead of just adding those numbers together, we're going to have to do inverse operations, right? What do we need to do here to both sides if we want to get B all by itself? We got to subtract 81, right? 121 minus 81 gives me 40. Still got b squared on the left. And now we take the square root of both sides, right? B squared gives me b on the left. Square root of 40. Let's go ahead and break that down. 40 breaks up into 8 times 5, 4 times 2, 2 times 2. So now b is equal to the square root of 2 times 2 times 2 times 5. What's the identical pair we can pull out here? 2. Pair of 2's, good. Now a 2 and a 5 are left underneath the square root. What are we going to do with that 2 and that 5? We're going to multiply them and get 10, right? 10. So we get b is equal to 2 root 10 what? Once again, feet. 2 root 10 feet. Now we don't know approximately what that number is, but we can estimate that the square root of 10 is somewhere in between 3 and 4. Right? And when we multiply that by 2, we end up somewhere in between 6 and 8, which would be shorter than our longest side, which is 11. So that checks out and works well for us. So very similar problem, but I really want you guys to see the difference between our setups based on what information is given. Are we given the hypotenuse? Are we given one of the legs? It's really important that you know the difference. Questions on the ladder problems before we go to the TV problems? How are we feeling about those ladder problems? Thumbs up, thumbs down, thumbs sideways. Wouldn't spend this much time talking about these ladders if we weren't going to see a ladder on the test. So definitely make sure you know what's up with that. All right, we got a square TV here, 40 inches tall. Right, square TVs aren't really a thing anymore, but back in the day, as you've probably seen pictures of older TVs, like I'm talking way back in like the 60s and 70s, TVs were square for the most part. So if you thought that's weird, we have a square TV, it's more of like an older thing. So if we have a square that's 40 inches tall, right, we're looking for the diagonal length. What letter is going to represent this diagonal line? A, B, or C? C, once again, C, right? Oh, whoops, 40 inches tall. So if our square TV is 40 inches tall, how wide is this TV going to be? 40 inches, right? It is a square TV. And all squares have the same size sides. So even though we're not given that we've got a width of 40 inches, we can assume based on the fact that it's a square that the length and the width are the same number, 40. So now we set up our equation, 40 squared plus 40 squared equals c squared. What is 40 squared? Perfect. 1600 plus 1600 equals c squared. That gives us what? 3200. And now we're going to break 3200 up. Now this can be a little scary because it's such a large number, right? We're going to have quite the factor tree here. Unless we think about it in a little bit simpler terms. We know that 3200 is 2 times 1600 because that's what we just did in the previous step, right? 2 times 1600. And although we're not really trained to notice this, 1600 is a perfect square, right? We just found out that 40 times 40 gave us 1600. So we can break 1600 up into 40 times 40. Now from this point, if we wanted to, we could break up the 40s into 8 times 5, the 8s into 4 times 2, and the 4s into 2 times 2. But that's a lot of unnecessary work. If we break down those 40s into their prime factors and pull them out, we're just going to have to multiply them again. So why don't we just leave it here? 40 times 40 times 2. underneath the square root. And what's our identical pair that we can pull out here? 40, right? We bring the 40s out. What's left over? 2. So C is equal to 40 root 2. What's my units here? Feet again? Inches. That's right. 40 root 2 inches. So we can, again, estimate that the square root of 2 is in between 1 and 2. So if we multiply that by 40, we get somewhere in between like 42 and 80. That's kind of a wide range. But it's definitely longer than the 40 inches across, right? Okay. Now number 4, we still got a TV, but now we're dealing with a rectangular TV, which oddly enough, I messed up the long and tall, but 12 inches long, 16 inches tall. It's an odd-shaped TV, but whatever. It's a rectangle either way. Now when we're looking for the diagonal length, right, it's the same exact thing except we have two different numbers here. 12 squared plus 16 squared equals C squared. $144 plus 256 equals C squared. What do we get when we add those up? 144 plus 256, that's 400, that's right. And 400 is a perfect square. We take the square root of both sides and we get C is equal to 20 inches. That's right. So if this was Samsung, thank you. So if this was Samsung or Sony or LG, whatever TV brand you want to talk about, they would market this as a 20-inch TV, right? The diagonal length of this TV is 20 inches. But if you brought out your measuring tape, you would see that it's really only 16 inches long. I talked about the TV stuff with you guys, right? Yesterday? Okay, cool. I just want to make sure. All right, question on the rectangular or square TV problems, figuring that out. Are we good on that? Okay, I feel like we're good on that. Finally, we're just doing the converse of the Pythagorean theorem. That's essentially just checking our work in a way. We got 10, 12, and 16. Which of those numbers needs to be my C? Right? 16. The longest side always needs to be C. And then we can just work our way up like so. 10 squared plus 12 squared equals 16 squared. Gives us 100. Plus 144 equals 256. And we get 244 equals 256. Is that true?
No.
No, it is not. So our answer is no. This is not a right triangle. The converse of the Pythagorean theorem is just verifying whether or not something is a right triangle or just a regular triangle. Right? 10, 12, 16, those would still form a triangle. It just wouldn't be a right triangle. It would look something like this. Right? Almost a right triangle, but not quite. A little bit, yeah, a little bit more obtuse than a right triangle would be. I don't know if this is exactly what it would look like, but it's close enough. Moving on down, 5, 12, and 13. 25 plus 144 equals 169. Sorry, I skipped the first step. What is 25 plus 144? 169. Is that true? Yes, it is. We do have a right triangle here. 5, 12, and 13. Now, some of you may be picking up on the patterns here, right? We keep seeing the same numbers over and over again. 169, 225, 400. That's because there's only a few special cases where the side lengths of a right triangle are nice whole numbers like this. There's only a few circumstances like that. I think there's only 4 or 5 different combinations for side lengths that will give us this type of triangle. There's 3, 4, 5, 5, 12, 13. There's, 10, 6, 8, 10, right? 36 plus 64 gives us 100. There's these special cases where if you start recognizing those, you're going to be able to answer these questions a little bit quicker, but it all comes with time. Here we got a triangular road sign with side lengths of 15, 15, and 20. I can already tell right away this is not going to work out, but let's verify. 225 plus 225 equals 400. That gives us, what, 450 equals 400. That's definitely false. Our answer here is no. We do not have a right triangle. Can anyone just tell me what type of triangle this would be, though? If it's got side lengths of 15, 15, 20. Anyone remember what type of triangle that is? Back from elementary school? If it's got two of the same side lengths. Starts with an I. Victor, you remember? Yes, an isosceles triangle. That's right, an isosceles. If you take a look over there at the colorful triangle chart, the second one over the orange one, an isosceles triangle, thank you, Andy, is a triangle with two of the same side lengths. That's what we have here. We got 15, 15, and then 20. So not an equilateral triangle. A little bit more, I don't know if it would be obtuse, but anyway. So that's that on 61. Any questions on that? I wanted to take a little bit more time than we normally do and go over it all kind of in depth because word problems can be a little bit trickier. And we are going to have a nice couple of word problems on our test on Friday, right? How many? Yeah. 2 or 3. 2 or 3. I don't know. 2 or 3. Something like that. All right. Go ahead and give worksheet